Hey everyone, and welcome. Today, we're going to crack the code on one of the planet's most incredible and vital weather systems, the Indian monsoon. This is a force of nature that literally shapes the lives of over 1 billion people, and we're going to break down exactly how it all works.
So you gotta wonder, right? What's really at the heart of it all? What turns the entire subcontinent's weather system completely on its head year after year? Well, that's the big question we're here to answer.
And the answer, really, is the monsoon itself. The word actually comes from the Arabic Monsoon, which just means season. But listen, it's not just about rain. It's about a complete 180-degree reversal of the main winds. This seasonal shift is the absolute engine of India's climate.
So to really get this massive weather machine, we're going to journey through its 4 key phases. First, we'll look at the engine that drives it all. Then, we'll witness its spectacular summer arrival. We'll follow its slow autumn retreat. And finally, we'll meet the other weather makers that define India's winter.
All right, first up, let's pop the hood and take a look at the monsoon machine itself. What are the fundamental forces that get these massive winds moving in the first place?
Okay, so it all boils down to something called differential heating. Sounds a bit complicated, right? But it's actually pretty simple. In the summer, the huge Indian landmass heats up way faster than the oceans around it. This heat creates a powerful low-pressure zone over the land. And, well, nature can't stand an imbalance, so cooler, moist air from the high-pressure ocean rushes in to fill that gap. That massive rush of air, that's the engine of the monsoon.
But wait, it's not just about the heat difference. There are a few other major players on the field. You've got the mighty Himalayas acting like a giant wall, trapping all that monsoon moisture over the subcontinent. You have these high-altitude jet streams steering the whole system, and even things happening thousands of miles away, like the warm El Niño current in the Pacific, can have a huge effect and sometimes weaken the whole monsoon season.
Okay, time for a quick check-in. The concept of differential heating we just talked about. Which of these geographical phenomena was it primarily given to explain? I'll give you a second. If you're thinking monsoon, you are exactly right. That heating difference is the absolute core of the whole thing. Okay, now that we know how the engine works, let's watch this machine roar to life. It's time for the main event, the arrival of the southwest monsoon, which brings something like 70% of India's total annual rainfall. It's a huge deal.
You know, the monsoon doesn't just trickle in. It arrives with a bang. This sudden, almost violent arrival, usually hitting the Malabar coast in Kerala around the first week of June, is called the burst. We're talking about a dramatic, sudden downpour that can last for days, bringing life-giving water for crops and just incredible relief from that intense summer heat.
Now this is where it gets really interesting. Because of India's peninsular shape, that big wall of wind and rain literally splits in two when it hits the land. You've got the Arabian Sea branch on the west, which is the stronger of the two, and then you have the Bay of Bengal branch to the east, which gets deflected by mountains and sweeps up into northeast India and across the Gangetic Plains.
And this map just illustrates their paths perfectly. You can literally trace the Arabian Sea branch moving up the west coast and pushing into the heart of the country. At the same time, look at the Bay of Bengal branch sweeping in from the east, bringing rain all the way up to the northern plains. So cool. This split creates some fascinating local effects. So here's a classic geography puzzle for you. Mumbai gets absolutely drenched with over 250 centimeters of rain, but Pune, which is just over the mountains, gets less than 70. Why on earth is there such a massive difference? The answer is this super cool concept called the rain shadow effect. So Mumbai is on the windward side of the Western Ghats Mountains, right? It gets the full blast of those moisture-packed winds. As the air is forced up over the mountains, it cools and just dumps all of its rain. By the time that air gets to the other side, the leeward side where Pune is, it's basically dry. The mountains cast a shadow of dryness behind them. So, we have these two massive branches traveling across the country, but where do they finally meet up and merge? What do you think? Well, they finally converge over the northern plains, in the region of Punjab and Haryana. Of course, what arrives must eventually leave. After months and months of rain, the entire system begins to reverse. It's time for the monsoon's slow farewell tour, which we call the retreating monsoon. Now this process is way more gradual than the big arrival. It starts up in the northwest around September. The low-pressure system over the land starts to weaken, high pressure builds up, and the winds begin to retreat southwards. The skies over northern India are pretty much clear by mid-October.
And this withdrawal phase creates this really unique phenomenon that people call October heat. The skies are clear, so the daytime temperatures shoot back up, but the ground is still super moist from all the rain. This combo of high temperature and high humidity creates this really uncomfortable, oppressive kind of heat.
And while the north is drying out, the retreating monsoon is having one last party. As those winds move back out over the Bay of Bengal, they pick up moisture all over again and deliver it to which part of India? That's right, India's east coast, especially Tamil Nadu, which gets its main rainfall for the year from this.
Finally, let's look at the last piece of the puzzle. You know, the monsoon is the star of the show, but it's not the only thing happening in India's climate. Winter has its own unique weather makers.
A really key feature of winter in North India is something called the Western disturbances. Now get this, these are actually storms that are born all the way over in the Mediterranean Sea. They travel east, and they bring this really crucial winter rain to the plains, perfect for crops like wheat, and of course, heavy snowfall in the Himalayas.
And we have to mention the Himalayas again. In winter, they play a completely different, but just as vital role. They stand like a colossal wall, blocking the freezing cold winds that sweep down from Siberia and Central Asia. I mean, without them, North India would be a frozen wasteland.
And beyond these huge systems, India is also home to so many important local winds. You've got the infamous Loo, those hot, dry winds of summer. You've got Kalbaisaki, which brings thunderstorms to the east, which is great for the tea crops. And then there are the mango showers, these pre-monsoon rains in the south that, yep, you guessed it, help the mangoes ripen.
All right, here's your final challenge, and it really brings everything we've talked about together. In just one sentence, why does the Tamil Nadu coast get its main rainfall in the winter? Think about what we said about retreating winds and big bodies of water. Drop your answer in the comments below. I want to see what you come up with.
And that's our look at India's absolutely incredible monsoon climate. If you enjoyed this deep dive and want more explainers and practice questions for your ICSE exams, you know what to do. Be sure to subscribe to our YouTube channel, the ICSE Learners Ace 2027. Thanks so much for watching.